In the last video, we looked at expanding perfect squares. So if that's the way forwards, then factorizing is the way backwards. Okay, so with expanding perfect squares, if they're in the form a plus b all squared, we know that when we expand an expression like this, we get a squared plus 2ab plus b squared. Let's reverse that. Let's say we have an expression in this form. Okay, so an expression in this form, a squared plus 2ab plus b squared. This can then be factorized. So in other words, we're going to bring the brackets back in as the perfect square, a plus b all squared. So as an example, if we're given the expression x squared plus 24x plus 144, when we factorize that, it's the expression x plus 12 all squared, and that's in factorized form. Okay, so in other words, the factors of x squared plus 24x plus 144 are x plus 12 and x plus 12. In fact, there's two factors that are in fact identical. Okay, likewise, an expression in the form a squared minus 2ab plus b squared can be factorized as the perfect square, a minus b all squared. Okay, so as an example, 4m squared minus 12mn plus 9n squared. So this one's a little bit, a little bit trickier, but I wouldn't say that much more difficult. Interesting to note that the first term and the last term are perfect squares in themselves. So 4m squared, the square root of that's 2m. 9n squared, the square root of that is 3n. Okay, but we have a negative 12mn sort of as part of this expression, part of the expanded expression. And 2m minus 3n, if we expand that, okay, we end up, in fact, with 4m squared minus 12mn plus 9n squared. Okay, so if you're ever asked to factorize something like this, look at the first and the last terms. Okay, in fact, when you square those, when you take the square root of those, you end up with the two terms inside the binomial. When you expand the binomial or just multiply the terms in the middle and then double it, you should end up with the middle term of the expanded expression. And do you? Let's have a look. 2m times negative 3n is negative 6mn. Double that, you get negative 12mn. So that's correct. Let's have a look at some examples. Okay, so let's factorize the following expressions. So the first one, x squared plus 2x plus 1. Okay, interesting to note that 1 is a square number. X squared's a square number, of course, because it's just x squared. And we have the middle term here, which is 2x. Now, I guess as a test, if you halve the middle term and then square it, you get 1. So we know this is going to be a perfect square. Okay, so this is going to be x plus 1 all squared. If you multiply the terms inside the binomial together and then double it, we should get 2x, and we do. Okay, so x times 1 is x, times 2 gives you 2x. X all squared is just x squared, 1 squared is just 1, and so therefore we're satisfied with that. Okay, you can also expand this manually and just check to see that your factorized version expands to the question, or what the expression is in the question. All right, so what about part B? A squared minus 6ay plus 9y squared. Again, interesting to note that the first term and the last term are square numbers. So we suspect that the perfect square expansion, this doesn't always work, so this is why we always need to make sure we check this, is going to be a minus 3y all squared, because the middle terms are minus, they're negative. Now, as a check, so we're going to check this. Okay, a squared is, well, a squared, negative 3y all squared is positive 9y squared, so that's okay. But what about the middle term? Let's multiply the two terms inside the binomial. A multiplied by negative 3y is negative 3ay. Double that, you get negative 6ay. So that's in fact correct. Okay. Another way, again, to check would be that you halve the middle term. In fact, the middle term is, in fact, well, the coefficient's actually negative 6y. I might just write this in a different color. So if you take the middle term, right, and in fact, it's negative 6ya. Okay, so we're only interested in the negative 6y because the a squared is really the first term. So negative 6y, halve that. Okay, so if you multiply that by half, we get negative 3y. And if you square that, you get positive 9y squared, and that works as well. So there's multiple ways to check this. I guess that's really the point that I'm trying to make. What about part C? 16x squared plus 56x plus 49. Again, let's look at the first term and the last term. They look like square numbers. Okay, so why don't we, I guess, come up with an attempt at factorising it. So we suspect that the first term of the binomial, the factorised binomial, is going to be 4x. The second term is going to be a 7, since that's the square root of 49. Now we just need to double check that this binomial, when we expand it, will have a positive 56x in the center, okay, or the middle term. 4x, so as a check, so we'll say check middle term. Right. So 4x multiplied by 7 multiplied by 2, okay, is equal to 28x times 2, which is equal to 56x, and that is equal to that. So therefore, we're happy. This is the correct answer. Okay, so I guess just as I guess it should be force a habit, right? Or if it's not a habit for you now, try to make it a habit. I think it's a good idea. Just check your work as you go along, or at least at the very end, spare a few seconds, go back and just check to make sure that you're on the right track with this. Okay, don't just factorize it or just give an answer and hope for the best. Okay, even if you have to estimate it, better than nothing. Okay, so what about the last one? 64x squared minus 16x plus 1. Now I'm going to do something a little bit different here, and I'm going to show you another method you could use. Okay, it's a little bit more of an advanced method, but still a very powerful one. Now we're suspecting that this is going to be a perfect square, which means that this will be in the form ax plus b all squared, and we really want to find what the a is and what the b is. Okay, that's always sort of what we're trying to find. So if we expand ax plus b all squared, what do we get? Okay, we end up with a squared x squared plus 2abx. So you multiply the terms in the binomial together and then double it, so it's 2abx plus b squared. Now, if you look at the original expression and then look at the expression that results from expanding ax plus b all squared, we can look at each of the terms and I guess try to sort of come up with the values of a and b. So a squared is equal to 64. I'll just in a different color. Okay. Therefore, a would be equal to 8, square root of 64. B squared is equal to 1. Okay. Therefore, B would also be equal to 1, since that's the square root of 1. So 2AB, does that give us negative 16? Okay. So this is where we've got to be very careful. So 2AB, okay, we want that to equal negative 16. Okay, so this is the coefficient here. So we have A is equal to 8, B is equal to 1. Okay, so 8 times 1, that's 8, times 2 is positive 16. So because the middle term is negative, this B here should be negative 1. Okay, not positive 1. So 2 times 8 times negative 1 should give us negative 16. So 2 times 8 times negative 1, in fact, does give us negative 16. So we've now found our values for A and B. Okay, so therefore, the answer is, 8x minus 1 all squared.